Hello, and welcome to the next video in this series. Let's talk about our thinking questions from last time. When in life will you be able to use your understanding of the inverse relationship between addition and subtraction? When I thought about this question, I thought about all the times in life when I don't have a calculator at hand and I need to be able to do subtraction problems that maybe aren't as easy to think about right in my head, and I have to do them quickly. When that happens, I think about the addition problem that I know that is in the same fact family, and then I automatically know my answer. So that's one way that I would use inverse relationships, maybe when I'm grocery shopping or when somebody is asking me how many more materials I need for a birthday party, things like that. So what most fascinates you about the inverse relationship between addition and subtraction? I would say what fascinates me the most is that you can take these same three numbers and say so many different sentences with them. You can say 4 different number sentences, and that's a lot. You can do a lot with those different number sentences. All right, so let's get started. Today we're going to be talking about double-digit addition. And there are a lot of different ways that you can go about solving double-digit addition problems. And when you do, we can think about it a lot of different ways too, and that's how we come up with all of our different strategies. Today we're going to talk about 2 of those strategies. You are going to need your work log or paper and a pencil, and that is all. So you can pause the video and go and get those now. Okay, I want you to solve these 2 problems on the board. We have 46 plus 5, and then we have a number sentence over here that says there are 28 loaves of bread on the shelf at the store. The manager restocks the shelf, adding 3 loaves of bread. How many loaves are there now? I want you to use whatever strategies you know that you're comfortable with in solving these. If that's a traditional algorithm, or if that's some other way, if that means drawing it out, whatever works for you. Go ahead and do that now and pause the video. All right, so first we're going to represent this number sentence as 28 plus 3. And the answer to that one is going to be 31. And the answer to this one is going to be 51. So if you got those 2 answers, then you solved it correctly. But we're still going to talk about some different ways for you to go about solving these today, because when you can understand what you're doing when you're solving them, you're more likely to be able to remember it later on, and that'll help you a lot. I'm going to model one strategy for you right now. It's called the partial sum strategy. And it helps us to pull apart numbers so that we can see and understand their place value, which can then help us in addition. So let's read the problem. A flock of geese are flying south for the winter. 26 of the geese start from New Hampshire, but then 63 more geese join them in Pennsylvania. How many geese are there by the time they arrive in the south? Let's think first, what's our number sentence going to be? We're starting with 26 and we're adding 63 more. So we're going to represent it by 26 plus 63. Let's start by pulling apart our 26. We know that there are 2 tens or 2 longs in 26. And we're using these base 10 blocks to represent our geese. And then we have 6 ones. Looking at this, we can tell that 26 is made up of 2 tens or 20 plus 6 ones. So 26 is the same thing as saying 20 plus 6. Now what about 63? Let's pull that one apart. We'll need 6 longs and 3 shorts or 3 ones. And then when we pull that apart, we see that we have 60, because we have 6 tens plus 3, which is the same thing as 63. Now, how are we going to use this to solve this problem? If we think about it, it's probably going to be a lot easier to add 60 plus 20, right? Because we know that 60 counting up 20 will get us to 80. But that we're not done yet. We still need to add up our ones. So we have 3 ones here, and we have 6 ones here. That gets us to 9 ones. And now, we simply need to add 80 plus 9, which will get us to 89. That is the partial sum strategy. Let's try 2 of these number sentences together now. Starting with 95 plus 47. I want you to pause your video and think about how you can split these numbers up. Go ahead and do that now. One of the ways you may have thought to split it up would be to say 90 plus 5, and then 40 plus 7. Because you know that there are 9 tens in 95 and 5 ones, 4 tens in 47, and 7 ones. Now we're going to add those together. So let's see. 90 plus 40. We can either use our base 10 blocks, or we can think in our head how we can solve this problem. We can even count up. So if we say 90, and we have to add 4 tens. So 90, 100, 110, 120, 130. So we know it'll get us to 130. The other way to do that would be to draw our 9 longs and then 4 more longs, and then you would trade 10 of them for our 100s block or our flat, and you would still have 3 tens left over, telling us that it's 130. But we're not done yet. We haven't taken care of our ones yet. We have 5 ones plus 7 ones. And what's 5 plus 7? This is a basic fact that you should probably have in your head. 5 plus 7 is 12. You can also use your ones blocks to count. So now we have 130 and 12. We're going to add these 2 together. We know 3 plus 1 is going to be 4, or 30 plus 10 is going to be 40. And then we have 100. So we split it up into tens first, because that was easier to think about. And then we split it up into ones. And then we put the tens and the ones together. And we got 142. Now let's take a look at 24 plus 13. I would like you to pause your video now and again think about how you're going to split this one up. And then think about how you're going to add it. Let's split up the 24 first. We know that this is made up of 2 tens and 4 ones. So 20 plus 4 equals 24. They're the same thing. And then we'll split up the 13. We know this is 1 10 plus 3 ones. Now we're going to add the 2 tens places together. So we have 20 plus 10. And using what we know about our basic facts, we know that this is going to equal 30. Or we can count up and say 20 plus 1 10. So you're only going to count up by 10 once. 20, 30. And then we're going to add our ones places together. So the 4 and the 3. And again, we're going to use our basic facts, or we can count up we know 4 plus 3 is 7. So this is the sum for our tens place, and this is the sum for our ones place. But that we're not done yet. We don't have a final answer. We still need to add our tens and our ones place. And we're going to get 37. I would like you to solve these two number sentences and a number story as well on your own. The number story says Tony loves to collect rocks. He already had 64 rocks in his collection, but then he went to the beach. He found 49 more rocks for his collection. How many does he have now? Go ahead and pause your video and work on that now. Let's see how you did. Let's split up the 55 into 50 plus 5 and our 14 into 10 plus 4. With this, we're going to add up 50 plus 10 to get 60, and 5 plus 4 to get 9. Because the 5 and the 4 come from our ones place, and the 50 and the 10 come from our tens place. Now, are we done? No, we're not. We still need to add up 60 plus 9 to get 69. And now what about this number sentence? Tony loves to collect rocks and he already has 64, but then he found 49 more rocks. So what is our number sentence going to look like? He starts with 64 and he finds 49 more rocks. So now how many rocks does he have? Using our partial sum algorithm or strategy, we're going to split up the 64 into 60 plus 4, and then we're going to split up the 49 into 40 plus 9. But are we done? No. We still need to add up our tens place and our ones place. So what is 60 plus 40? We have 6 tens and then we're adding 4 more. Let's count up for this one. 60, 70, 80, 90, 100. And what's 4 plus 9? We can use our basic facts or we can count up for this one. We know that it's going to be 13. Are we done now? No, we're not. We still have one more step. We need to add 100 plus 13 because this is only the sum of our tens place and this is only the sum of our ones place. So 100 plus 13 is going to equal 113. We're going to try another strategy now for double-digit addition, and this one uses a number line. So my number sentence is 82 plus 49. I'm going to start my number line at 80 because I know I'm going to be, my starting point on the number line is going to be 82, so I don't need to start back at 0. As you know, number lines can represent just a part of all the numbers that there are. So, and I think I'll go up to 150 because I know with my estimation that it's not going to go over that. So 90, 100. So here's my number line from 80 to 150. I only labeled the numbers at the tens, but there are hash marks in between to show me where all the ones places are. So let's start at 82. That's right here. Now, just like in the partial products strategy, we're going to split apart our 49 into the 2 place values. So 40 plus 9. This is going to help us to jump forward or hop forward. I know I need to hop forward 4 tens or 40. So I can go 82 to 92, to 102, to 112, to 122. And I just hopped forward 1, 2, 3, 4 tens, or 40. Now I still need to hop forward 9 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that lands me at 131. So I know that 82 plus 49 equals 131. And I did that using the number line. Now let's try these two together. We have 34 plus 77, and then we have a number sentence here. There are 28 students in Miss Smith's 4th grade class. There are 61 students in the other 3 4th grade classes. How many 4th grade students are there? Knowing what I know about these two number sentences, I know that on our number line, I'm going to start at 34 for this problem, and I'm going to start at 28 for this problem, which we can represent as 28, because we have 28 students, plus 61 students in the other 3 classes. So, where do we want to start the number line? I'd like you to pause the video and try to create a number line that will work for these two number sentences. It's possible that your number line isn't going to look exactly like this, but it shouldn't start any later than 28, and it shouldn't end any sooner than, let's say, 120. And I chose 120 because I used my estimation skills to decide what the highest possible number could be. Okay, so let's start with 34 plus 77. Where are we going to start for that? We're going to start at the 34. So let's see, where's our 34? So we're going to start right here. But how far are we going to hop? How many times are we going to have to hop? Let's look at our 77 and pull this apart just like we did with partial sum. 70, because we have 7 tens, plus 7, because we have 7 ones. So 70 plus 7, I'm going to hop forward 7 times when I'm counting by 10. So I go 34 to 44 to 54 to 64 to 74 to 84 to 94 to 104. Let's see, did I count forward enough times? 1, 2, 3, 4, 5, 6, 7. Or we could say 10, 20, 30, 40, 50, 60, 70. But I've only counted up 70. I still need to count up 7 ones. So 104, 105, 106, 107, 108, 109, 110, 111. All right, so I just counted up 7 times. And I landed at 111. So 34 plus 77 is going to equal 111. Now let's take a look at this number sentence. So there are 28 students in Miss Smith's 4th grade class. There are 61 students in the other 3 4th grade classes. How many 4th grade students are there? So we've already written our number sentence, 28 plus 61. Go ahead and pause your video and think about which number we're going to start on the number line, and then how many times we're going to have to jump forward to get to our final sum. Okay, so you're going to start at the 28, which is down here. But then how many hops are we going to have to make? We're going to pull apart the 61 just like we did in partial sum and say 60 plus 1, because it's made out of 6 tens and 1 1. So we're going to hop forward 60 first, so 28 to to 38, to 48, to 58, to 68, to 78, to 88. And then I still have to hop forward one more. So 88 to 89. And that's how I know my answer is 89. Go ahead and try these two number sentences on your own using the number line. 69 plus 43 and 58 plus 82. Go ahead and pause your video and work on that now. Your two answers should be 112 and 140. On this one, you would have started on the 69 and then jumped forward 40 plus 3 times. And then on this one, you would have started at the 58 and then jumped forward 80 plus 2 times. I have one more number story for you to solve, and it might make you think a little bit outside of the box, and that's a good thing. I would like you to use a number line to try to solve it. Zyshawn and Tyrese are hosting a barbecue. Tyrese already had some hot dogs in his freezer. Zyshawn bought a package of 3 dozen more hot dogs. Now they have 47 hot dogs. How many hot dogs did Tyrese have in his freezer? I'd like you to pause your video and work on this now using the number line strategy. How did you start this problem? You probably looked and saw that Zyshawn bought a package of 3 dozen. 3 dozen hot dogs. We don't know how many individually yet though. We just know it's a package of 3 dozen. But we do know that a dozen is 12. So 3 dozen, with 12 each, so each dozen has 12, is going to equal 36. So we know Zyshawn bought 36 hot dogs. So how many did Tyrese have? If we write our number sentence like this, 36, because we know Zyshawn already has those, plus blank, because we don't know how many Tyrese has, equals 47, because we do know how many they have together. We can then use these numbers to help us on the number line. I'm going to start our number line at 30, because our first number on it is going to be 36, and I'm going to end it at 50, because I know I'm not going to go beyond that. So using the number line, I'm going to start at 36, right here. I don't know how many I'm going to have to jump forward, but I do know that I'm going to land at 47, which is right here. I can either jump one space at a time, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I jumped 11 spaces. That means that from 36 to 47, there's 11. There's 11 in between. So I started with 36 hot dogs, and then I have to add 11 more to get to 37. So that tells me that Tyrese had 11 hot dogs in his freezer. This is actually really closely related to what we're going to be doing in our next video, so try and keep this in mind. Here are think about it questions for this lesson. Which strategy, partial products or counting up on the number line, makes the most sense to you, and why? And then, can you or would you use these strategies with triple digit addition? Why or why not? I want you to think about those between now and the time you watch the next video. See you later.